We are Daisukii Onii-chan team from English Community class. Our team only I, Toai, and my partner, Hoang.
In today's digital test, we rely heavily on online services, promise sites, and apps to cloud-based platform behind the scene. There are sophisticated mechanisms that help ensure the service remains fast, reliable, and accessible. Even during peak using time, that mechanism is called loss balancing.
Imagine a scenario, right? You have decided that you are going to run a website, and this website is going to be immensely popular. You need to build it to scale to serve millions of users, all of whom are accessing it at the same time. So imagine that single user, and what is his experience going to be like? So you got your guy, he out here, and he got a laptop, right? And so on his laptop, he want to open out some new website. So we is going to send the traffic out into the internet, which we are going to put a little cloud there in on the internet. And then as it transmit through the internet to the actual server. What way is the data is hosted? It's going to get down there, and it's going to get to the application server. And that application server is going to be what actually serve all of the data back via the internet to his laptop so that he can view what is going on the website. Now that's fine if you just got one person who access your website at the time. What if your what if you have 10 people as one? Well, that absolutely is probably going to be fine to do that. What if you have 10,000 people who are accessing at once? And so that when you get into this interesting scenario when you can saturate out this application server. And so if you think about an infrastructure level of definition of an app server, you can scale them up to a certain size, but you got limit in how big the application can be. So what do you do? Alright, well, you need to scale them out, right? Instead of having one app server, you might have three, or you might have four, or you might have five, or you might have 10, or you might have 10,000. You are going to horizontally scale those applications so that you have enough of satisfying your customer. But how do you know how much scaling you need? And more importantly, how does this guy with his laptop get to the application server that need that he need in order to be successful? And the answer to that is in between your customer and all of your app servers, you are going to put a lot balance.
What is a load balancer? Is it a hardware device or is it could be a software device? And that load balance is going to the better all the traffic that coming in from the internet. And it's going to divide what's go to the server, what's go to the server, what's go to the server, and so on and so forth. It's also going to provide and collecting information. So the application server down here, they can be talking to the load balancer. They can be saying, hey, I'm only being used 20% of the time. Maybe you don't need me right now, and the loss balancer can then dynamically scale or auto scale and turn that application server off if you don't need it have the right down code. That's why it all of the app servers are checking in and they are saying, hey, I'm super busy, I'm running at 85, 90% duration. It's time to bring in half. Then that run balancer can hit that auto scale service again and it can say, hey look, I need another one. I need another app server to try and decrease my loss. And so when for talk about cloud native attribute, it is a K component. That load balance is a K component because that load balancer is going to assign out that traffic to all of different application server. And the app server, they're also going to down here, right? And they're going to talk a common database type because you don't want to get into a goofy script brand scary kernel with your database, but you're going to get the database that we need, and they're going to server that backup to end the customer directory. So that's how you split up your database. That's how you serve it up. But so now that we're in load balancer, we said it's going to decrease with allocation server to get the traffic right. How does it define what to do? And so Let's get our three most common sentinels right.
Load balancing direct and control internet traffic between either application server and the system or silent. As a result, it improves an application availability, scalability, security, and performance. First is application availability. Server failure or maintenance can increase application downtime, making your application unavailable to visitors. Load balancer increases the fault tolerance of your system by automatically detecting server problem and redirecting silent traffic to available server. You can use load balancing mostly as easier. Run application server maintenance or upgrade without application downtime. Provide automatic disaster recovery to backup site. Perform health checks and prevent issues that can cause downtime. Secondly, this application scalability. You can use load balancer to direct network traffic intelligently among multiple servers. Your application can handle thousands of silent requests because load balancing does the following. Prevent traffic bottleneck at any one server. Predict application traffic so that you can add or remove different servers if needed. And reduce the to your system so that you can scale with confidence. Load balancer comes with built-in security features. Add another layer of security to your internet application. They are a useful tool to deal with distributed denial of service attack, in which attacker root an application serves with millions of calls concurrent requests that cause server failure. And load balancer can also do the following: monitor traffic and block malicious content. Automatically redirect attack traffic to multiple backend servers to minimize impact. Route traffic through a group of network firewall for additional security. And finally, this is the application performance. Load balancer improve application performance by increasing response time and reducing network latency. They perform several critical tasks such as the following: distribute the load evenly between servers to improve application performance, redirect guidance requests, and to geographically close servers to reduce latency, ensure the reliability and perform of physical and virtual computing resource.
Layer 4 L4 load balancer, network load balancer. Layer 4 load balancer operates at the transport layer of the OSI model. They can make forwarding decision based on information available in network layer protocol, such as IP address and port number. Key feature of layer 4 load balancer: transport layer operates as transport layer, DBC, says UDP, basic load balancing, retrieves traffic based on IP address and port number. Efficiency: faster processing as it doesn't inspect the content of the data package. Network address traditional NAT can perform basic NAT to high server address. Layer 7. Layer 7 load balance operates at the application layer of the OSI model. They can make load balancing decrease based on content, including information such as URLs, HTTP header, or cookie. Key feature of layer 7 load balancer: application layer operates of application layer, HTTP, HTTPS, content-based routing, distribute traffic based on content-specific information, advanced routing. Can make intelligent routing devices based on application-specific data, SSL termination, capture of terminating SSL connection. The other side of load balancing is dynamic and static. Dynamic load balancing algorithm estimates the current state of the server before discovering traffic. The following are some examples of the dynamic load balancing algorithm. Let's connection. A connection is open communication channel between the client and the server. When the client sends a phone request to the server, they authenticate and database an active connection between each other. And the late connection method, the load balancer check with a server had a fearless active connection and send traffic to the server. The method of some to all connection require equal processing power for all servers. Western list connection algorithm assumes that some servers can handle more active connection than other. Therefore, you can assign different way of capital to each server, and the load balancer sends new line request to server with the less connection by capacity. Windows response time. The response time is the total time that server can take to process incoming request that send a response. The less responses time methods combine server response time and the active connection to determine the best server. Load balancers use this algorithm to ensure faster service for all users.
The first example of load balancing algorithm is round robin. So had IP address that tells the silent way to the same request. The IP address is a long number that is difficult to remember. To make it easy, a domain name system have website name to serve. When you enter a web with our Ruby methods into your browser, the request first go to our name server, which return our IP address to your browser. In the round robin method, an alternative name server does the load balancing instead of specifying hardware or software. The name server returns the IP address of different server. Is the server farm turn by turn or in the round robin question? The secondly is weighted round robin. In weighted round robin load balancing, you can assign different weight to each server based on their productivity or capacity. Server with higher weight will indicate more incoming application traffic from the name server. And lastly is IP hash. Is a IP hash method. The load balancer perform a mathematical computation, can hashing on the silent IP address. It converts the silent IP address to a number, which is then mapping to individual server.
Improves reliability and availability. Load balancer ensure high availability by distributing traffic among multi-servers. If one server fails, another can take over, reducing downtime, better performance, and scalability. It's optimize response time and handle a larger number of the requests by balancing the load across service server. This allows the system to be scaled horizontally by adding more servers as needed. Effective resource utilization by evenly distributing the load balancer and tools that all servers are used effectively, preventing overloading some services while others are ADA. Fault tolerance. Load balancer can detect failed server and automatically redirect traffic to healthy servers, weak action fault tolerance, and system resilience. Flexibility is maintenance. Load balancer allows servers to be taken offline for maintenance without affecting the availability of service, making server maintenance easier. Improves user impression by distributing requests to server with low weight latency or that upload get to users. Load balancing improves response time and overall user experience. Security entrainment. Load balancer can act as a reverse proxy, adding an extra layer of protection by hiding server identity. They can also help mitigate the dot attack by distributing and masking incoming traffic.
And there is negative of load balancing. First, it adds complexity. Introducing a load balancer into system at the extra layer of the infrastructure, making the overall architecture more complex to manage and troubleshoot. Secondly, can be single point of failure. If the load balancer is failed, it can become the single point of failure for the entire system. To avoid this, redundancy examples multiple load balancer is often needed, which add cost and complexity. Higher cost. Implementing load balancing solution can be costly, especially when using hardware load balancer on multiple instances for redundancy. Cost also increase with other future like SSL termination. Latency and bottleneck. The load balancer itself may introduce latency as it processes and routes incoming requests. If not properly configured, it can become a bottleneck affecting the overall system performance. Dependency on health check. Load balancer really on health check to determine the status of packet itself. If health check are not configured correctly, it may lead to traffic being sent to unhealth or underperforming server. And complex configuration. Proper configuration and turning of a load balancer require technical expertise. Misconfiguration can lead to inefficiency, such as uneven loss distribution, security vulnerability, or even system failure. Session persistent challenge. Answering session persistent when a silent request is always directed to the same server. Also can sticky session can be challenging. This might require additional mechanics on configuration.
Who will use load balance? Anyone who needs to ensure the availability, scalability, performance, and fall to listener to update system can benefit of using a load balancer. This include organization of all size. From small startup managing a growing allocation to less enterprise hosting critical infrastructure. Example, a large-scale web application, code-based application, companies with multi-server, companies with global user base, online gaming platform.